Hey there, universe nerds. Take a look at a piece of gold, maybe a ring, a necklace, or even a coin. That gold didn't come from Earth. It wasn't made in our sun. It was born in one of the most violent events in the universe, a neutron-star collision. These cosmic crashes are not only spectacular, they're the forges of the heaviest elements in the universe. Today, we're diving into what neutron stars are, how they collide, and why their explosions shape the very matter we're made of. So, what exactly is a neutron star? When a massive star goes supernova, its core collapses into an incredibly dense ball of neutrons. A teaspoon of neutron star material would weigh billions of tons. Neutron stars are city-sized, only about 20 kilometers across, but they contain more mass than our sun. They spin rapidly, sometimes hundreds of times per second, and have magnetic fields trillions of times stronger than Earth's. They are already extreme, but when two of them collide, the results are even more astonishing. A neutron star collision begins when two stars in a binary system both explode as supernovas, leaving behind neutron stars. Over millions or billions of years, the pair spirals closer as they lose energy through gravitational waves. When they finally collide, the explosion is called a kilonova, brighter than a nova, but not quite as bright as a supernova. The energy released in a kilonova is staggering, lighting up space and sending ripples through the fabric of space-time. The most famous detection came in 2017, when the LIGO and Virgo observatories detected gravitational waves from a neutron star merger, known as GW 170817. Just seconds later, telescopes around the world caught the light from the explosion. For the first time, scientists observed both gravitational waves and light from the same event. It confirmed neutron star collisions as the source of heavy elements like gold and platinum. In fact, that single collision likely created more gold than Earth contains in total. But how do these collisions make gold? Inside the explosion, conditions are so extreme that atomic nuclei rapidly capture neutrons in a process called the R process, rapid neutron capture. This creates heavy elements beyond iron, including gold, silver, platinum, and uranium. Every piece of jewelry, every bit of precious metal we value so much was forged in cosmic fire billions of years ago, before finding its way into the dust that became our solar system. Neutron star collisions also help us understand the universe in other ways. By studying the gravitational waves and light they emit, scientists can measure cosmic expansion and refine the value of the Hubble constant. They also reveal the behavior of matter under conditions impossible to reproduce on Earth. Neutron stars are natural laboratories, pushing physics to the limit and showing us how matter behaves at densities beyond imagination. And they're spectacular to watch. The light from a kilonova changes over days, shifting from blue to red as heavy elements form and the explosion cools. Telescopes capture the glow fading over weeks, while gravitational wave detectors record the echo of the collision. Together, these signals give us a complete picture, sound and light from the universe's most dramatic factories. Neutron star collisions are rare, happening maybe once every 100,000 years in a galaxy. But when they do, they leave a lasting legacy. They enrich galaxies with heavy elements, seed future planets with the building blocks of life, and remind us of the cosmic connections between stars and ourselves. The gold in your jewelry is older than Earth, born in a crash of stars across the galaxy. So, where does gold come from? Not from mines or markets, but from the sky. From stars collapsing, colliding, and creating heavy elements in brilliant kilonova. Next time you see gold, remember, you're holding a piece of a neutron star collision, a fragment of one of the universe's most violent yet creative events.